Hey, how are you guys doing today? Sorry, that was very odd. Anywho, you might get a monstrosity like this. In fact, I did give you a monstrosity like this, where they just give you the voltage of your power source and they give you the resistors, and you're trying to figure out what gives with the rest of it. What's the voltage drop and what's the current? And it turns out if you just apply Ohm's law, which is what current is the voltage divided by the resistance, and Kirchhoff's rules. So Kirchhoff or Kirchhoff, there's two H's there. If you just apply these two rules and this one law, you'll be able to solve all this stuff. The trick is to just kind of first figure out how much current this battery is pumping out. And to do that, we need to know what the equivalent resistance of this whole monstrosity is. So we just have to do it just like we were going to eat an elephant, right? One bite at a time. So first thing we'll do is we'll focus in, why don't we focus in on this, right? These two things are in parallel, and we can combine those as it stands. And so I would do the 1/4 plus the 1/12, and what would that be? That would be what? This is the same as 3/12 plus 1/12, which is 4/12, and that would give me what? Wow, yeah, so these two together would be 1/3. Actually, no, you've got to take the reciprocal, right? Because that equals 1 over the parallel resistance. So I could replace this with a 3 ohm resistor. Okay, that whole thing, if I swap that out, I could replace it with a 3 ohm resistor, going from here to here. Same thing, let's go up here. First off, these two are in series with each other. So let's just call that 6 ohms. Okay, and then these 6 ohms are in parallel with this 6 ohm resistor here. And so that's 1/6 plus 1/6, which would give us 2/6, which would give us 1/3 again. So I could replace this entire thing here with just a 3 ohm resistor. Okay, now it's getting a little bit cluttered. So what I'm going to do is I'm going to redraw this entire circuit, except I'm going to collapse some of this stuff because I can, right? Because I found the equivalent resistances of certain parts of it. And so when I come around here through this top loop, right? If I go up through this top loop, there's 3 ohms of resistance, and this total thing is 3 ohms as well. So if I put these two together, being in series, that means there's a total of 6 ohms of resistance at the top. Okay, and then if I go around this bottom path, I will have a 3 ohm resistor, right? If I replace these two with just a 3 ohm resistor, that's in series with this 9 ohm resistor, and well, we know that's 12 ohms. Wow, that really made that circuit look really simple. Well, you know what? Let's go ahead and combine this 6 ohm and this 12 ohm resistor that are in parallel by applying our rules that 1 over the parallel resistance is 1 over the sum of the reciprocals of the resistances. And so it's that 2/12 plus 1/12, that's 3/12, which simplifies down to 1/4. So this whole thing up here I could replace with the reciprocal of 1/4, which is 4 ohms, right? That whole thing's 4 ohms up here. And so, let's go ahead and redraw this one more time. So I've got 2 ohms down here, and up here this was a 4 ohm resistor, and they're both connected to this 18 volt battery. Okay, awesome. So wait a minute. According to Ohm's law, current is the voltage over the resistance. I have a total voltage of 18 volts and a total resistance of 2 plus 4 ohms. Okay, of course 2 plus 4 is 6. 18 over 6 is 3 amps. So this 18 volt battery is pushing out 3 amps. Nice. So wait a minute. That doesn't branch off anywhere, right? All 3 amps have to go through this 2 ohm resistor. So that means that my voltage drop across that 2 ohm resistor, I'll just take that current of 3 amps times the resistance of 2 ohms, and that will give me 6 volt drop. Sweet. Okay, cool. Well, that current gets up here, and there's lots of different things, lots of different ways you can think about this. Right now, if I wanted to, I could figure out the voltage drop from this point to this point using Kirchhoff's loop rule. And, you know, we might as well go ahead and do that. The other thing you can do is right off the bat, just use Kirchhoff's junction rule. That says that if I've got 3 amps going into this junction, I'm gonna have 3 amps flowing out. So some's gonna go up this way, some's gonna go down this way. Well, since this resistance is twice as much as this resistance, this branch is going to get twice the current that this one does. So 2 amps is going to go up through the top, 1 amp's going to go through the bottom. Okay, but if you don't know that, like, you're going to have to figure out this stuff out using the loop rule, right? Which states that through any closed loop, the sum of the voltage drops is going to be equal to 0, or rather, I'm sorry, the sum of the voltage gains plus the voltage drops is going to be equal to 0. In other words, if I start right down here, I would have 18 volts gain, and then I would have, we said, what was that? 6 volts lost across that resistor, and then we're going to lose another certain amount of voltage from this point to this point. Right? And whatever that voltage drop is, that would have to get me back to 0. And you probably really easily see there must be 12 volts from here to here, right? So we know there's a total of 12 volts from this point to this point. Okay, if I took my voltmeter, that's what it would read. Now that makes life easier again, because current is voltage divided by resistance. My goodness, that's Ohm's law again. So what I'll do is I'll just take the voltage of 12 volts and divide it by this resistance of 12 ohms, and that will tell me, yes, just like I said before through logic and reasoning, and applying Kirchhoff's junction rule, that 1 amp has got to go down that way. And if I do 12 volts over 6 ohms, that means 2 amps must be going that way. Now, if you look at this 3 ohm resistor right up here, that is getting the full 2 amps. Oops, 2 amps. Okay, and I might as well just multiply current times resistance, 2 times 3, to get a 6 volt drop right there. Okay. Now, of course, that 2 amps, it splits. Some goes here, some goes up here. But what I want you to see is, since I've already dropped 6 volts across this resistor, and I know there's a total of 12 volts between this point and this point, or this point and this point if you prefer, that must mean that there's a total of 6 volts across this 6 ohm resistor. Right? Because the voltage drop across this plus the voltage drop across this has to be 12 volts. Okay? And now, wow, I can just use current Ohm's law again to find the current through that 6 ohm resistor would be 1 amp. Well, what do you know? Kirchhoff's rules are going to come in now again, because look, we said 2 amps was flowing into this junction and 1 amp was going across this way. Well, if that's true, the current in has to equal the current out, so there must also be 1 amp going across this top. All right, so both the 1 ohm, I'm right in the wrong place. The 1 ohm resistor and the 5 ohm resistor, they'll get 1 amp through them, right? The same current is going to travel through both of them because it doesn't branch off between the 1 and the 5, okay? And then we're going to just use Ohm's law again. Of course, we're going to rewrite it, delta V equals current times resistance, to figure out the voltage drop across the 1 ohm resistor is 1 volt, and across the 5 ohm resistor is 5 volts. Well, that's pretty, because look, if we go up here, remember we need a total of 12 volts between here and here. So I get 6 volts plus 1 plus 5. That's going to get me back to 12. Or if I go around the bottom, 6 volts, another 6 volts. Yes, I've got 12 volts from here to here. That works. We're going to apply the same logic down here. This 9 ohm resistor, we know already that it had 1 amp going through it. So 1 amp, because again, there's 12 volts from these 2 points, and there's 12 ohms of total resistance between those 2 points. And so that would mean that there is 9 volts, right? Current times resistance across that 9 volt resistor. Well, remember again, from this point to this point, there's a total of 12, so there must be 3 volts across this point. So across the 4 ohm resistor, there's 3 volts. And across the 12 ohm resistor, there's 3 volts. We're going to apply Ohm's law. Again, my goodness, it seems like we're doing that all the time for good reason, right? We are doing it all the time. So V divided by R, that would be 1/4 or 0.25 amps. And here we've got 3 over 4, that's 0.75 amps. Did you guys smell that? That smells right, because look, you've got 1 amp going this way, 0.75 and 0.25 amps going that way. They join together, they do make 1 amp. Okay, this all checks out. What are we lacking here? Oh, we didn't get the current. We do know the current through this 2 ohm resistor, right? It's the same as the battery current. That was the 3 amps. I forgot to put it up here originally. Okay, what is the total resistance? Well, we already found that the total resistance was 6 ohms when we simplified everything down to here and said it had to go through this 2 ohm resistor and the 4 ohm resistor. Or you could also, again, apply Ohm's law. Resistance is voltage divided by current. That is 6 ohms of total resistance or total load that this battery sees when you hook up all these resistors to it. Okay. Last column is just power. Power is just, oh, I guess there's one other thing we have to do is say power is I times delta V. Okay. So the power dissipated from the battery is just 3 times 18. It's 54 watts. Okay. Now, if the battery is putting out 54 watts of power, that's its power output, I'm going to guess that if I add up all the power dissipations through all the resistors, they're going to have to add up to 54. And that just makes sense because the battery is producing 54 joules per second of energy. And that means the resistors have to then, in total, convert 54 joules per second of energy into heat, of electrical energy into heat. So let's go ahead and multiply these out. So I get 18 here. I get 2.25. These are all going to be in watts. I'm not going to write down the W's. I get 0.75, 9, 18, 6, 1, and 5. So if we add those up, 6, 12, 30, 39, 39.75, 42. Uh-oh. Did I do something wrong? I must have. No. Oh, 54. I'll have to figure out what I did wrong. Oh, this is 12, silly.